Hey guys, this is 3.3, properties of functions. 3.1 was the first in this unit. It was just about identifying a function. If you have a relation, can you tell it is a function or it is not a function just based on the equation and the algebra without looking at the graph? If I give you an x, can you get a y? So if you are given an input, can you get an output? And the different types of functions or the different forms: mapping, numeric, verbal, and in points and on a graph. And then 3.2 was if the function is graphed and you don't even know the equation, can you tell that it's a function and how much information can you gather from it? This one is properties of functions. So we're going to be looking at the equation, but mostly the graph, and just learning about different terms that we can apply to the function. Okay. So to begin with, we have even functions and odd functions. We have even, odd, or neither. It could be neither. An even function is symmetric with respect to the y-axis. And I know you guys have done this a lot. So respect to the y-axis just means if I fold it along the y-axis, this side will meet or match this side exactly, right? If you only have the equation and you want to know if it's symmetric with respect to the y-axis, you put in a negative x for all the x values and you simplify to see if you get the same original function back, okay? You can check the points. If x, y is on the graph and it is an even function or symmetric to the y-axis, then negative x, y is also on the graph, or opposite x, y. For every odd function, it will be symmetric with respect to the origin, which means when you flip it all the way upside down, it will look exactly the same. For every point x, y on the graph, the point negative x, negative y is also on the graph. So it's going to be the opposite x value and the opposite y value, okay? And in the equation, f of negative x will end up looking like negative f of x, okay? If you can multiply every x value by -1, and the equation looks the same as multiplying the entire function by a -1, that would be an odd function, okay? And you can also say it's neither even nor odd, okay? So for this, it says determine whether each graph is the graph of an even function, an odd function, or a neither, okay? So if you look at this, you think, would the graph lie on top of itself if I folded it along the y-axis? So if I folded it here, is it mirroring itself? No, right? So it is not even. If it is odd, does it look the same upside down as it does right side up? Okay, so if you look at it, and if it helps me to describe it, and then I'll turn it upside down and see if that description still matches it, okay? So this opens, gets bigger to the right, and it crosses x at a negative x value, right? Or has a negative x intercept. If I turn it upside down, it no longer opens to the right, right? It no longer crosses x at a negative value. So it used to look like this. And now it looks like that. Not the same. So this one I would say is neither. Okay. The second one, would the graph lie on top of itself if I folded it along the y-axis? does one side mirror the other side? If I folded that, would it be the same as that? Yes. So it is even. Every point xy on the graph also has the point negative xy. So if I said this was point negative 3, 3, this is the point 3, 3. So every point xy has a negative xy because it is even. All right, and the last one. If I folded it along the y-axis, would it lie on top of itself? No, right? So it is not even. If I turned it upside down, would it look the same as it did right side up? So let's describe it. It's on the left-hand side, not the left or right. On the left-hand side, it is below the x-axis. On the right-hand side, it is above the x-axis, right? It crosses right at the origin. So if I turn it upside down, is that still true? The left-hand side is below the x-axis, crosses at the origin, and the right-hand side is above the x-axis. That is still true. So it used to look like this, and it still looks like this. So this one is odd. That means if I have the point, what point would this be? 5, 2. I will also have the point negative 5, negative 2. So that is the difference between even functions and odd functions. Can you tell me whether it is even, odd, or neither? Okay, and we are using this rule, okay? So an even function f of negative x equals f of x, all right? Odd f of negative x equals negative f of x. So all we're gonna do, and I got that from here, right here and right here, is turn everything into f of negative x and see if it goes back to its original equation, if it looks the same as when we make everything negative, or neither, right? It can also be neither. Letter A, and let's put them down. Letter A, f of negative x equals 2. Instead of x, I'm writing negative x squared plus 3. Okay, and we're just going to simplify this. So over here, let's remember what happens to negative x squared. Negative x times negative x, right? Negative x squared becomes negative x times negative x, and negative times a negative is a positive. So we can simplify it to just x squared. So when we say 2 negative x squared, I can simplify that to 2x squared plus 3. And we see that that is the same as the original. So what we say is f of negative x is the same as f of x. So therefore it is even. All right. Let's do b. G of x, x to the third plus 3. So let's do g of negative x is negative x to the third plus 3. So here we did negative x squared. Let's do negative x to the third. A negative times a negative becomes a positive x squared times a negative x. And positive times a negative becomes a negative. So we're back to negative x to the third. It does not simplify to be positive. It stays negative. So g of negative x will look like negative x to the third plus 3. Okay, so we know it's not even because that does not equal x to the third plus 3. So we say it's not even. Let's see if it's odd. So it ends up being negative x to the third plus 3 and negative g of x looks like this. Negative x to the third plus 3. So we distribute that negative. Negative x to the third minus 3. That is not equal to this one, right? Negative x to the third plus 3 is g of negative x. And negative g of x is negative x to the third minus 3. So it's not odd. We say this is neither. And remember, there's no difference between f of x and g of x. They're just two different variable choices you can use. Letter C, they use h of x. So h of negative x is negative x to the third plus 4 to the negative x. Okay? So we already know from up here that a negative x to the third remains negative. And then a positive 4 times a negative x becomes minus 4x, right? That is not equal to the original, right? X to the third plus 4x. So it is not even. And then let's do negative h of x to see if it's odd. Okay, negative h of x, we'll just put a negative sign in front of everything. X to the third plus 4x. And I will distribute that like it's a negative 1, okay? Negative 1 times x to the third, negative 1 times positive 4x. Becomes negative x to the third minus 4x. And our h of negative x was negative x to the third minus 4x. So it is odd. So odd means h of negative x was equal to negative h of x. Odd. Okay. All right, letter D. F of x is 1 over x squared plus 8. So f of negative x will be 1 over negative x squared plus 8. Negative x squared is just x squared. That is the same as our original f of x, which was 1 over x squared plus 8. So it is even, right? And if you find that it's even, you don't have to check that it's odd, right? Because a number can't be odd and even. This one was even. F of x. Oops, sorry. F of negative x was the same as f of x. So we said it is even. Okay. So we said this one's even, this one's neither, this one's odd, this one's even. Let me pause for a second. Okay. Yes, it's recording. All right, let's look at Desmos. So we have the first one we said was even. So we'll show that one. It's even because if I fold it along y, it will look the same on both sides. It mirrors itself, right? And g of x, we said is, that was b, we said it's neither. It does look like it mirrors, right? Or it looks like it is symmetric according to the origin, but it's because of this 3 that it isn't. So if we took away the 3 and just put it at 0, that would be a mirror. But because it's way up here, if I flip it around, instead of crossing at +3, it'll cross at -3. So that's not mirrored along the origin. It does not look the same right side up as upside down. Letter C was h of x, and we said that letter C was odd. Odd means symmetric with respect to the origin. So if I turn that upside down, it would look the same. And the last one, zoom that one in. That one we said is even, symmetric with respect to the y-axis. It mirrors itself along the y-axis. Okay. Now let's talk about increasing, decreasing, and constant. A function is increasing on an interval. So all of these say on an interval. It just means for part of the graph, okay? An interval is part of the graph. We don't care what it's doing, or we're not talking about what it's doing for the entire length of the graph. We're just asking about intervals, one piece of the graph, okay? Here we have x1 and x2, so we would say the interval f of x1 to f of x2. That's what we would call that, okay? A function is increasing if the graph continuously rises from left to right along the entire interval. It's decreasing if the graph continuously falls from left to right on the entire interval, and it is constant, means it doesn't change. The height is constant from left to right on the entire interval, okay? Now, the way we write it in interval notation is with brackets. x1 to x2, it is rising, right? Or increasing. This says x1 to x2. x1 to x2, it is decreasing. And here, x1 to x2, it is constant. Determine the intervals for which the function is increasing, decreasing, constant, positive, and negative. And it goes from, the whole graph is from -4 to +4. It's just hard to see because I printed in black and white. So it starts here, ends here. Okay, determine the intervals for which the function is increasing, decreasing, constant, positive, and negative. Okay, so we'll start with the first three because we know what those are. All right, and I want you to remember that we are only using the x-axis. So when we looked at this, we only had an x point, x1, x2, x1, x2, right along the x-axis. We don't care how high, well, yeah, we don't care how high it is for y. We are only interested in labeling the x. We describe it using the x, okay? So we're labeling the intervals by looking to the x-axis. When is it constant? And that is hard to tell because, again, I didn't color my line. Here, it is constant. So we can say it is constant. Hold on. Let me show you a little bit more clearly. If you only looked between these 2 points, you would only have a flat graph, right? So that's what they mean. So it is constant from -4, 0 to -2, 0. -4, -2. There's no y, okay? So when is it increasing? It is increasing, right, along these two. So that would be -2, 0. And that was 3 to 4, right? -2, 0, comma, 3 to 4. Oops, it should be brackets. You can put a U between them. That wouldn't be wrong. But on Pearson, they only want a comma. So don't do the U. But it just means union, like a union of a set, okay? And then decreasing. Ignore that I didn't spell decreasing correctly. It will be decreasing from 0 to 3. And you see that I did do brackets, so it's not a parentheses, because even though, like, we have -2 included here and -2 included here as constant and increasing, you're like, how's that possible? It's because it's a distance, right? So I'm going from something to -2 and it stays flat. Here I'm starting at -2 and it's going up because I'm subtracting, right? I'm subtracting a distance. So it can be constant at 2 and increasing at -2, okay? All right, so let's talk about positive and negative. Positive get them off the graph, off the camera. Positive means it is above the x-axis. And so, as you can guess, negative means below the x-axis. It can also be neither positive or negative, right? It could be on the x-axis. So it's -4 to -2, neither positive nor negative. So positive would be from -2 to 2. And here I can't put brackets because it's on 0 at -2 and it's on 0 at 2. So these would just be parentheses. It does not include the number that lands on the 0. And then is it both negative or below the x-axis from 2 to 4. Okay. Now let's talk about local maximum and minimum. A function has a local maximum value at any point that is higher than all the other points around it, on top of any hill. That means it has to go up and come back down like a hill. It can't look like this. It can't go up forever. It has to go up and come back down like a hill. A function has a local minimum value at any point that is lower than all the other points around it. The bottom of any valley comes down and has to go back up. Has to come down and go back up. Okay. So here, there is one point that is locally higher than all the other points, right? We'll say x is c. So where x is c is our local maxima, and it is local max is f of c or y, okay? So it's kind of challenging the way they ask you to write it. You find that point and then they're going to ask you what x equals and what it is. If they say what it is, you put the y, okay? Usually. They just separate them a lot. So they'll say, what is the y value? And then what is it? Give the x value, okay? They never want a point really in Pearson's. They say, what is the x value? And then what is it? How high is it? Okay. And then here, same, x is c, the max is f of c. So here, can you locate any max values? Okay. Please note that there are arrows here, which means it's going to get wider and taller forever in both directions. Okay. The max value is the top of any hill. Okay. And sometimes they will have two. Okay. Top of a hill. Local min values would be bottom of a valley. And because it's local, you can have more than one. So locally, this is the lowest. Locally, this is the lowest. Even though this is lower than this is still a local min. All right. So there's only one local max. These are not local maxes. They go on forever. We don't know. There's no hill, right? So we'll say the local max value is at x equals 3 and is, at x equals 0 and is 3. Okay, so that's a way they may ask you to write it. They also may say that the max of the local max of f of x, oh, sorry, the local max, the local max of f is f of 0 equals 3, because we know that is where x goes and that is where y goes, all right? It's like confusing and I'm making it more confusing by all my mistakes. The local max is at x equals 0 and is 3. The local max of f is f of 0 is 3, okay? Local min values, the bottom of the valley, right? So we would say it's at, let's do this one, at x equals -2 and is, then we just put y, and is -1, or local min of f is f -2 equals -1. And then we have one more. We have another one at x equals 1 and is 0 high, okay? Or f of 1 equals 0. So we have one local max, 2 local min. So you can have more than one. Where are the intervals on which f is increasing and decreasing? All right. So it is, even though the arrow is facing this way, we always go from left to right, okay? So you're reading it like you read a sentence. So this is going down, and this is going down. The way I would write that is just, it is increasing, nope. And where it is decreasing. It is decreasing from, well, that's an arrow, actually. So I have to start at -infinity. The arrow means it is going to get wider and taller forever in the direction of that arrow, okay? So from -infinity, it decreases to -2. And from 0 to 1, okay? It is increasing from -2 to 0 and 1 to infinity. I don't know the last number of infinity, so I just have to write infinity. And we know that infinity always gets a parenthesis, okay? Absolute maximum and minimum is always higher than all the other points. It's the highest number on the graph, okay? So sorry. So the difference here is the word the, right? The highest, the lowest, absolutely, okay? So there's only one highest point and there's only one lowest point. This one happens to be both a local max and absolute max at the same time. Okay. This one can be the local min and absolute min. Okay. It does not have to be a hill or a valley. All right, let's practice these. We're finding absolute and local max and min values. Okay, so let's number them 1, 2, 3, 4, 5. Number 1. The local max is 3, 6. Oops, I don't want us to write it like that. X equals 3 at 6, okay? The absolute max is also X equals 3 at 6, okay? The local minimum is X equals 1 at a height of 3. And the absolute minimum is X equals 5 at a height of 2. I'm going to show you my notes because they look much nicer. So for 1, the local max is X equals 3. I don't want to write this all out and have you waiting for me. X equals 3 at a height of 6. The absolute maximum is the same. The local minimum is X equals 1 at a height of 3. And then the absolute minimum, there's only 1. X equals 5, and it's a height of 2. So it's lower than this one. That's why it's the absolute lowest. Number 2, this is important. If the point is hollow, it is not included in the graph. Just like in previous math classes on a number line, you would go like this, and it would mean greater than, but not including, right? So this point is not included in the graph. So we say there's no local max. No local max, because we don't know the closest point to this one. They only gave us this point and they told us it wasn't included, okay? There's also no absolute max because we don't know any number except the number that's not included. For the local minimum, there is none because there are no valleys, right? There's only sharp endings. The absolute minimum is where X equals 1 and it's at a height of 3. Okay. So for number 3, the local max is none. There are no hills. There are no hills at all. The absolute max is where X is 6 and a height of 3. Okay. There are no valleys, so we have no local min. This all stays at 1, so it goes too long. There's no local minimum. The absolute minimum, there is none because no point is lower than the others. No point is lower than the others around it, and no point is lower than others in the graph. All of these stay at the same height. All right, number 4. Number 4, local max, none, because there are no hills. Absolute max, X equals 0 at a height of 6. Local minimum, none, no valleys. Absolute minimum, none, because we're moving toward infinity. Okay. And number 5, local max, none, because it does not include the 0.35. It's a hollow circle. Absolute max, none. Again, this is going down towards infinity. This is going up towards infinity. Okay. So that means there's no highest number of infinity that I can write down. Local minimum is X equals 5 at a height of 3. this one. It's the bottom of a valley. The absolute minimum, because 2, 2 is not included, I can't identify the point closest to 2, 2 that is not on the graph. So that's why we say that there is none. I cannot identify it. They didn't give me enough information. Last one, average rate of change. Have you heard of rate of change before? It is just the slope, right? Rate of change is the definition for slope. Okay. It is called average because we don't have a straight line. We have a curved line, and we're just trying to like guess between here and here about what is our slope, okay? The average rate of change between 2 points on the graph of a function is the slope of the line between the 2 points. So even though the 2 points are not connected by a line in this graph, you draw a line over it and find the slope of that line and call it the average change, okay? So we have an equation, f of x equals x squared plus 1, and then we want to find the rate of change from point 0 to 1. Yeah, this from the 0 point to the first point, from the first point to the second point, and then from 0 to the second point, okay? It won't be as close to the true rate of change because of the distance between the points, right? So this is not a line, but if I were to think about a line being drawn between the 2 points on that function, what would the slope of that line be, okay? So we just need to use this equation, which is the slope, the equation for finding slope on these points. From x, all right, from x as 0, right? This is x as 0. This is x as 1. This is x as 2. All right, it just doesn't look like it to me. Yeah, no, it is. Okay. So this is x equals 0, x equals 1, x equals 2. Okay, I believe them. Yes. What can I do but? All right. X equals 0, x equals 1, x equals 2. All right. So part A said from x equals 0 to x equals 1. For this equation, I need y values too, right? Luckily, I don't have to guess at these. I can put it into the equation. So when x is 0, y equals 0 squared plus 1, which is 1. When x is 1, y is 1 squared plus 1, which is 2. All right, so our points are 0, 1. That'll be my x1, y1. And this point will be 1, 2, x2, y2. Oh, sorry. Okay. Now I just use the slope formula on them. M is y2 minus y1 over x2 minus x1. 2 minus 1 is 1. 1 minus 0 is 1. So my slope is 1. Rise 1, run 1. B, we said from x equals 1 to x equals 2, if x is 1, y equals, well, we already knew that. Y equals 2. If x is 2, y equals 2 squared plus 1, which is 5, right? So now my points are 1, 2, and 2, 5. x1, y1, x2, y2. M is 5 minus 2 over 2 minus 1, 3 over 1, which is a slope of 3. Rise 3, run 1. Last one. From x equals 0, which we know is 0, 1, to x equals 2, which we know is 2, 5. x1, y1, x2, y2. M is 5 minus 1 over 2 minus 0, which is 4 over 2, which is 4 divided by 2 is 2. Rise 2, run 1. All right. And that is all. That was the average rate of change. So the average rate of change from 0 to 1 was rise 1, run 1. The average rate of change from 1 to 2 was rise 3, run 1. And then it's kind of like the average of 1 and 3. The average rate of change between 0 and 2 is up 2 over 1, up 2 over 1. Okay, so that is the end. We now know how to answer, is a graph even, odd, or neither, based on its symmetry, if I just looked at the graph, and then also based on changing f of negative x and simplifying and saying, is it like f of x? Then it's even. And then f of negative x equals negative f of x means it's odd, right? And that would be symmetric on the y-axis, and this would be symmetric along the origin. We know how to say, is a graph constant, increasing, or decreasing? We know how to tell if a graph is negative or positive. We can find absolute maximums and absolute minimums, local maximums and local minimums. So if you can do all of that, congratulations. That was everything you've had to learn today. See you next time.